this is maybe, I think, the area in technology that is changing faster than anything else. And it's almost like, to me, the revolution that we saw before with software, right? When software was introduced, and the first companies came along and really kind of changed the world as we know today, is happening again with machine learning. So I think that is kind of like software 2.0 in some ways. So we're going to talk about that today and kind of go over some of the examples, how it affects different industries, and also like how it matters for, especially for emerging economies and in a place like Brazil, because I believe it actually matters a lot. I think I lived through, the mobile or cell phone revolution in Brazil, and if you live in the U.S., maybe you took for granted that you had access to a phone line. In Brazil, that was never the case. It was very rare. People used to rent their phone lines or sell them. It was an asset. You could have a business on top of it. And then mobile phones came and changed everything, and we leapfrogged that. I think with machine learning, I think that some of that will be happening again. Yeah, so I like to start with this, and I borrowed this from a couple of people that I really admire. Ray Kurzweil, which actually works for Google, and he's one of the, I guess, fathers of machine learning. And also Steve Jefferson, which is kind of one of the partners at DFJ. And you think about the Moore's law, right? So this thing that computers, or originally it was a number of transistors, in a chip, kind of grow like every couple of years, kind of they double, and you can measure in different ways. And this one here is measuring, kind of like calculations per second per cost in dollar, right? And when you think about Moore's law, you think like, oh, maybe that's something that Intel invented, or Gordon Moore invented at Intel. But reality, and this is like a slightly different version of it, which I really like. It shows that this exponential growth in compute, right, and the ability to compute information has been happening actually a lot longer before even computer chips were available. So if you look back in that chart, you can see as you go down to the left that we go from transistors to valves, vacuum tubes, and then even before that to mechanical devices that were also kind of like early days computers, right? And this is an exponential curve. It looks like a line here because that's on a kind of logarithmic scale on the left. So it's like every step is a order of magnitude improvement. And you can see it doesn't stop. It just keeps on going, right? And it's interesting too that as it goes up, the leading platforms change, right? So maybe at some point it was Intel in some cases, or Apple, and then these come and change, and then new entrants come. So you can see at the top you have now, for example, NVIDIA, right? As they become a very important company in pushing some of the latest machine learning and virtual reality, augmented reality. So our ability to compute is increasing dramatically. So what is that allowing us to do? So this is an interesting example, and basically this is it's like a contest that happens every year, in which there's a database of images, right? It's called ImageNet. It's being created with, it has 1,000 different categories of things and pictures of those things, right? And every year we put together all of the best machine learning, artificial intelligence, computer vision minds, and they come and they try to develop a machine learning model, right, that can actually correctly classify these images, right? So you can see some of those images at the top. Here's a container ship, and then the machine, which is the red bar, says, oh, I believe this is a container ship with like high confidence, or a scooter, or a leopard, even a mite. I wouldn't be able to identify that one. On the left side is a mite, and the machine picks that up, other than a different kind of insect, right? And the chart on the bottom, on the left, shows the progress that these different teams, and these are teams from universities, from companies, how they have performed at each year of the contest, right? So in 2010, you can see that, and you can see in the blue, little blue dots on the left, you can see that the worst team, right, was getting the answers maybe like 80% of the time wrong, right? So it's pretty bad. And even the best team was only at 30% getting the right classification, right? And you can see that they improved somewhat over the years. Then in 2012, something really different happens. There is a team that outperforms everyone else by a huge margin. So it's that first orange dot there in 2012. And that was the team that basically used a new technique called deep learning, right? And deep learning, even though it's like the principles existed, for many years, it's only now that we have the compute and the data to be able to really use it in a meaningful way. And then you can see the next year, all the teams pretty much adopt, kind of deep learning techniques to be able to do this. And they all perform much better. And then in 2014, yet again, and you can see they're all kind of getting closer and closer together. And they're getting to like about 7% for the best team. A human being has tried to do this classification, and I think that the human being best, like least amount of error is about 5%, right? So 5% of the time they get it wrong. Now, I think the last time this contest was held, the best team using a computer in machine learning did about 3% wrong. So they're already superhuman in their ability to identify these images, right? So you can see how these things are progressing. And this is maybe one of the fastest areas in machine learning that's happening today. Super important for everything from a self-driving car to having a robot that can help someone in a hospital to all kinds of different problems, because you can recognize objects in a natural scene. So, but there are some bumps along the way. So this is another interesting example. So this is, anyone, I think here in the room, most people would look at that and say, well, that's a panda, right? And the machine actually does a pretty good job at saying this is a panda with 57% confidence, right? It's pretty good confidence that this is a panda. But, it's possible to add some specially crafted noise to that image and turn into this other image here. I think I imagine everyone in the room here, unless there's any AI or robot here, which maybe is possible given it's Google, would recognize that image on the right as also being a panda. And yet, the machine now says 99% confidence I know what this is. But now it thinks it's a gibbon, which is a completely different animal, right? It's a kind of monkey. So as you can see, we've made a lot of progress, but there is still some gotchas along the way to make this truly resilient, right? And there's a lot of research on this right now. This is, kind of thinking about adversarial machine learning, when you have an adversary that's trying to fool the algorithm, almost like when you look in the desert, you think you're seeing something, but you're not, because it fools your brain. This is the way to fool, the machine's brain, right? And so there's a lot of research on how to try to prevent this and make algorithms more resilient. I also wanted to say that I think now, and I know there are many startups here in the room, and I think I want to call this out because I think now is the time, right? I think that there's some of the things that have been happening. Actually, in the last 30 days, we had a couple of announcements that I think are very, very important. One is Google themselves. They just opened a data center in Brazil. It's a Google Cloud in Brazil, hosting data there. And what I see that's very important as well is that then you have access to a lot of the machine learning in the cloud that Google provides within the Brazilian territory, have good latency, good response times. So very important for you if you're developing. Now, machine learning in the cloud, running these algorithms in the cloud become very straightforward, even in Brazil, right? And now you have that capability locally. The other announcement that I think is also very important was Apple's latest conference when they launched the new iPhone. And one of the things that was kind of like part of the software, part of the announcement, but also the hardware, is that now they are making it very easy for a developer to embed a machine learning model, something that makes decisions based on learned experience from data in their apps, right? So if you're developing an app now, it became very easy to do that. Apple actually has a couple of models that are examples. You can embed that. One recognizes text. The other one, I believe, it recognizes voice or sentiment analysis. So this is becoming very, very easy, right? So it's like the tools are there, right? And they're available everywhere. And now even, if you look at the Brazilian market, it's well served. And I think this is something else that I saw, and it's my last slide, and we'll get the panel here. I think AI is already disrupting Brazil, and I think there's more disruption that's going to happen. So, like call center is a very big business in Brazil, also in places like India and elsewhere. And there is a lot of expectation that with chatbots and better ability to do natural language processing, right, interpret what the user wants, that these call centers are going to be disrupted. So this is actually from the magazine Isto É, which is Dinheiro, which is an important business magazine in Brazil, and they recently were saying that their research is showing that 85% of the call centers are aiming to be a virtual call center by 2020. So there's a lot of people, right, that are employed there. And out of their, kind of a group of startups that they surveyed, 80 of them already are developing AI machine learning products. Still a very small share. I think we should expect that to grow a lot. And these startups, and you can read the article on Isto É, they're across a broad spectrum, from finance to recruiting, law firms, e-commerce. And I think the other thing that I thought was interesting is back to talent, right? Very hard to find the talent to work in data science, in machine learning, to solve these problems. It's hard here in Silicon Valley. And for me, it's like we hire. I was talking to someone before this presentation. We hire a lot of people from universities directly, right? Because there ain't just enough people on the market. And in Brazil, I think the startups also are doing kind of similar things. They are partnering with, ITA, which is like one of the top technical universities in Brazil, or they're partnering even with universities outside of Brazil. So thank you, Margarisi, again. I mean, this is a fantastic event. And this is, for the folks here that have been to a BayBrazil event before, you may be getting used to this. But, to me, year after year, it's amazing to see how, in this room or before at Stanford, we managed to bring some of the brightest minds that are, either in technology or in the nexus between Brazil and Silicon Valley. So that's what BayBrazil is about. And to kind of echo what Margarisi said in the beginning, I joined BayBrazil because I was really trying to find, where does Brazil meet Silicon Valley technology, and how does Brazil get to, the 21st century, right? And I think that's true, an organization like BayBrazil. So if you haven't joined BayBrazil yet, this is your opportunity. Make sure to sign up, become a member, and join us for our events.